Welcome to Math with Mr. P. Today we are going to be doing 6th grade math, chapter 6, lesson 7. We're talking equivalent expressions today. Vocabulary startup. When addition and or subtraction signs separate an algebraic expression into parts, each part is called a term. The numerical factor of a term that contains a variable is called the coefficient. A term without a variable is called a constant, and like terms are terms that contain the same variables, such as x, 2x, and 3x. So, for example, our expression is 3x plus 7 plus x. There are three different terms, 3x, 7, and x. Those are three different terms, three different values that are being separated by a operation. 3x and x are like terms. These are ones that we can actually combine. 3x plus an x will make 4x. So I can actually combine those two. But because I can't add a variable to a random number because I don't know what it equals, 3x plus 7 plus x would end up becoming 4x plus 7. Because remember, the order in which we do this doesn't matter. But because 3x and x are both like terms, I can combine them because they are alike. All other whole numbers would be considered like terms. So if I had something like this, let's wait for the digital whiteboard to kick on since I didn't have it open and ready to go. But if I had an expression like, let's say 12 plus 4x plus 5. There are three terms here. So they're still terms, remember. Numbers being separated by an operation. Something that is happening to these numbers. So 4x, there's no other x's here, but however, these whole numbers here, 12 and 5, are going to be like terms because I can add them. Remember, since we're adding all of these as a different type of operation, I can combine these two. This will then become 4x plus 17. Or if you put 17 plus 4x, that's fine. Typically, we like to put the variable first, but either one would be acceptable. So in this case, 12 and 5 are like terms because they're whole numbers that don't have a variable. They are the same. In this case over here, 3x and x were like terms because they both had x. If you had two different variables, say this was 3x plus 7 plus y, I would not be able to combine 3x and y because they are not like terms. Even though they are variables, they are not the same variable because x and y could be completely two different values. Therefore, we don't combine them. Label the graphic organizer below. So again, 4n, 2n, and 9 are all terms. There are three of them. 4n and 2n are like terms. They are like terms. Therefore, I would be able to simplify this down to 6n plus 9. 4 plus 2 would be 6. 6n plus 9. Andrew's mother gave him a computer game and $10 for his birthday. His aunt gave him 2 computer games and $5. The expression x plus 10 plus 2x plus 5, where x represents the cost of each game, can be used to represent Andrew's birthday gift. So this is according to if the games all cost the same. So again, his mom gave him $10, which is where this 10 here comes from. They also gave him a computer game, which is what the first x, because we don't know how much a computer game is. His aunt gave him 2 computer games and $5. So the 10 and the 5 represent money, and the x values represent the cost of each game. And since there's 3 of them, x plus 2x, that would make 3x. The coefficient of the term 2x would be 2. 2 is the coefficient in that one, and 2x. The numerical factor of a term that contains a variable is called the coefficient. So the numerical factor of a term that contains a variable is called the coefficient. The numerical factor meaning the number that's in front of the variable. So in this case, the coefficient is 2 in 2x. So this 2x representing 2 video games that his aunt gave him, but his mom also gave him 1. So let's go ahead and write this out again. X plus 10. So it's x plus, why did I write 10? Dyslexia. X plus 10. So this is his mom's gift. 1 computer game and $10. Plus 2x that his aunt gave him 2 games and $5. We would combine like terms here first. So x and 2x are like terms because they have x as a variable. And 10 and 5 are like terms because they're whole numbers that don't have a variable. So x plus 2x would make 3x, plus 10 and 5 would make 15. So he got 3 computer games at the value of which they are, we don't know yet, plus $15. How many terms are in the expression x plus 10 plus 2x plus 5? There are 4. There's x, 10, 2x, and 5. There are 4 terms. Then we combine the like terms to simplify it more. Now 3x plus 15, there will only be 2 terms after we have combined like terms. Simplify expressions with one variable. To simplify an algebraic expression, use properties to write an equivalent expression that has no like terms and no parentheses. So for numbers, the example is 3 plus 3 equals 2 times 3 or 6. So we would change it. 3 plus 3 is the same thing as 2 times 3. With variables, x plus x is the same thing as saying 2x. There's 2 x's. So that's why we write it as 2x when we add. Simplify the expression 4 times 6x. We are using the distributive property again. Or actually, no, we're not. Kind of. 4 times 6 would be 24, which is what we have down here. But with the x at the end, we're still multiplying it by that. Because over here, we have 4 times 6 times x. 4 times 6 times x again with the parentheses. So this one, parentheses indicate multiplication. Because remember, it's 4 times 6x, because 4 is outside of 6x in parentheses, which means it's multiplying. We can change this, because remember, the order in which we multiply does not matter. So again, what 4 times 6x is saying, since 6x equals 6 times x, when I put the 4 on the outside, this is actually saying 4 times 6 times x. And we talked about this in a previous lesson. The order in which we multiply doesn't matter. This is the commutative property. It will equal the same thing. So I can do 4 times 6, which is 24, times x, which would be 24x. This is still saying 24 times x, but because we don't know what x equals yet, we can't solve it. So basically, we want to simplify that and just say that it's 24x. Simplify each expression. So down below, again, we have all multiplication. This one's addition, and then this one's addition. Remember, the order in which we multiply or add does not matter. So 3 times x times 11, we could do 3 times 11 first, which is 33, and then multiply it by x, which is 33x. So that one would be 33x. If you want to do 3 times x, which would be 3x, then multiply by 11, it would still be 33x. These are 3 x's adding together. So we have 1, 2, 3 x, because we're adding them. We're not multiplying. And over here, 7x plus 8 plus x. So I'm going to go ahead and do this on our big whiteboard. This is 7x plus 8 plus x. That 8 looks wonky. Now remember, our like terms are what we can be combined. Since this has an x in it and this is an x, these are the only 2 that I can add together. I cannot add 8 with it because 8 does not have an x in it. So this will become 7 plus 1x will be 8x plus the whole number 8 because there's no x in it, and they're not like terms. So this will become 8x plus 8. 3 friends will pay X dollars, we don't know what X equals, each for admission to a museum plus $1 each to view the mummy exhibit. A 4th friend will pay admission but will not view the mummy exhibit. Write and simplify an expression that represents the total cost. So the expression 3 outside of the parentheses, inside the parentheses, x plus 1 plus x represents the total cost. Now look at this part here. We're going to go ahead and change the color of our highlighter. Cost of admission and exhibit for 3 friends. So 3 friends are going to go into the museum, so they have to pay the the X dollars. Hence why it's 3 on the outside. The number X, or the letter X, represents the number of the total cost of the museum ticket, plus $1 because they're paying $1 to see the mummy. The other friend is just paying to get into the museum, which is X. X represents the number of the cost of the ticket for the museum. So when we write it down like here, 3x, or 3 outside of the parentheses, x plus 1 plus x, we'd use the distributive property as we've learned. So this will be 3 times x, which will be 3x, if it'll let me write, and then 3 times 1, which will be 3, which is what we have here, 3x plus 3 plus the x that we had left over. We're going to combine like terms. 3x and x together will make 4x, and we still have the plus 3 left over, so we'll add plus 3. So the total cost for these 4 friends, 3 of which are going into the museum and going to the mummy exhibit, and 1 who is only going into the museum, does not want to see the mummy exhibit, will be paying 4 times x dollars plus $3. Let's do these got it's, and let's see if we can get this. Write and simplify an expression for the total cost of 6 friends, so I'm going to highlight here 6 friends, to go to the museum if only 4 friends view the mummy exhibit. So let's get this situated. 6 friends are going to go. So it's going to be 6 times x, because everybody needs to pay for the museum. Only 4 friends are going to visit the mummy, okay? So 4 friends will pay for the museum plus the $1 for the mummy, okay? Plus 2 friends who are only going to go into the museum, because remember, 4 plus 2 is 6. So this is how this is written. So again, let me slow this down and show you. 6 friends are going. Okay, so 6 times x. So we're going to do this. Museum. 1, 2, 3, 4, 5, 6, because 6 friends are going. So 6 people are going to pay for the museum, but only 4 friends, 1, 2, 3, 4, want to go see the mummy. So 4 of them are going to go see the mummy. 2 of them are not. Hence why I put 4 outside x plus 1, because there are 1, 2, 3, 4 friends who are going to go see the mummy. So they each were paying $1 extra, plus the 1, 2 friends, or 2x, who are not going to go see the mummy. So this would be my expression. 4 friends going into the museum and seeing the mummy, and then 2 friends who are only coming to the museum. Now, they said to write and simplify an expression. So we wrote an expression, and now we're going to simplify this. 4 times x would be 4x. 4 times 1 would be plus 4, plus 2x. This is our new expression down here. It's still not simplified because remember, I have like terms. This 2x and this 4x combined can make this 6x plus 4. So remember, 6 people are going into the museum, and only 4 of them are going to go see the mummy, hence why there is only $4 extra being paid. And that's it. Simplify expressions with 2 variables. Properties can be used to simplify or to factor expressions with 2 variables. Compare the effects of operations on numbers to the effects of operations on variables. So over here we have 3 plus 3 plus 4. That's the same thing as saying these two 3's combined can become 2 times 3 plus 4. Over here, x plus y, 2x's, 2x plus y. We actually combined these two. So they want us to simplify the expression 14y plus x plus 22y. Now, here's the deal. I understand the parentheses are here, and we have to do what's in parentheses first. In this case, since it's all addition, we technically don't need to follow the rule of the parentheses because it's commutative property. The order in which it gets added doesn't matter. And I know there's 3 different terms, so technically associative property. So even though the parentheses are there, because we're adding everything, it doesn't matter. So 14y plus x plus 22y does not need the parentheses. We are now going to combine like terms. Since this is a y and this is a y, those are the only two that are going to be added. So 14 plus 22 will be 36, and then we can add our x. Now, notice that x comes before y. When we use variables, we tend to like to put them in order, from x being first in alphabetical order, and then y. If you put 36y plus x, again, because of the commutative property, you're not wrong. I'm not going to mark you wrong, but just it's kind of an OCD thing for mathematics that the lower letter, the letter comes first in the alphabet, gets put before, so it would be x before y. Again, 36y plus x, I would still accept it. All right, so let's try to simplify this one. 4 times, and then in parentheses, 2x plus y. We're going to use the distributive property. 4 times 2x plus y. 4 times 2x plus y. The 4 will be distributed into each one. 4 times 2 will be 8 with the x at the end, plus 4 times y will just become 4y. And that's it. That's literally it. Factor 27x and 18y. So this is going to be tricky. It's going back to the last lesson that we learned. We need to factor out 27 and 18. We're going to do prime factorization of each. We're going to ignore the variable next to it. So it's 27 and 18. We'll change this color. So let's do 18 first. I know 18 is 2 times 9. 9 can be broken down into 3 times 3. The 2 will come down. There's the prime factorization, just like it says over here. 2 times 3 times 3. 27 will be a little bit different, and it will be 3 times 9. And then 9 can be broken down into 3 times 3, bring down the 3. So it'll be 3 times 3 times 3. These 3's are in common, just like it shows here. That common 3 and that common 3. Notice they also put x and y at the end, which is completely fine, because we're going to have to bring them back anyway. Since the two 3's are there, 3 times 3 is 9, so it will be 9 on the outside. Find the greatest common factor of 20. Oh, no, but it still does want us to factor it. Why didn't it give us the answer? Oh, it is giving us the answer down here at step 2 because I'm not paying attention. So we did find the greatest common factor of 27 and 18, which is 9. 9 goes on the outside just like here. Write each term as a product of the greatest common factor and its remaining factor. Again, 27 has that leftover 3. So it'll be 3, but because there was an x with it, it'll be 3x. Plus, over here, 18 has the 2 left over, but because there's a y attached, and that's how that will be. I understand they wrote it down here weirdly, but this is the correct answer, just like we wrote it over here. So we are factoring things out. Just ignore the variables. Just ignore the variables for that time. If for any reason the variables on both are the same, then the variable can go either on the inside or the outside. It wouldn't matter. But because we have an x and a y that are completely different, we're going to keep them inside separated by the plus sign. So 27x plus 18y becomes 9 outside of the parentheses inside 3x plus 2y. And this is it. This is our last one. Let's do these examples together. So remember, when it says simplify, they want us to combine like terms or actually use the distributive property to simplify it. When it says factor, we're going to be making these into prime factorizations is what we are trying to do. We're going to be making these prime factorizations, and then we are going to come up with a factored out answer. So let's start with E. Simplify 3x plus 9y plus 2x. 3x plus 2y plus 9x, is that what it was? No, 9y and 2x. Okay, so now that I have it written correctly, there's no distributive property or anything like that. All I'm doing is combining like terms. 3x and 2x being the like terms. And remember, the OCD of mathematicians is they want x before y. So 3 plus 2 will be 5x. And since this is the only thing left over, and addition is what's happening, it'll be 5x plus 9y. And that will be my answer. And that's it for that one. Pretty simple, straightforward, easy. For the second one, they want us to simplify 7 outside of 3x, and I believe it was plus y. This one we're using distributive property. The 7 times the 3x and the 7 times the y. We'll do a different color now. 7 times 3 we know is 21, but because the x is attached, we will put the x. This plus symbol will continue down, and 7 times y is the same thing as saying 7y. And that is our answer for that example. And with our last example, this one's a little trickier because we're factoring. Notice it says factor. 12x plus 8y. 12x plus 8y. These numbers or variables are going to come into play, but we're going to ignore them for now. We are going to prime factorize 12 and 8. 12 is 2 times 6. 6 is 2 times 3. Bring down the other 2. So we have a prime factorization of 2 times 2 times 3. 8 will become 2 times 4. And the 4s will become 2 times 2. So the prime factorization of 8 becomes 2 times 2 times 2. These two are uncommon. These two are uncommon. And remember, we look for the greatest common factor. So since these are uncommon, we do 2 times 2, which is 4. 4 will be on the outside of our parentheses, plus and whatever numbers are left over. For 12, it was 3. Notice there's an x with it, though, so that'll become 3x. And for 8, the leftover number was 2, but because there's a y with it, it'll become 2y. The reason for this is, when I distribute, it will become this. 4 times 3 is 12. With the x will become 12x, plus 4 times 2 will be 8. With the y becomes 8y. Exactly what we had here. And that's all we did to factor. So my answer is, with it being factored out, will be 4 outside of the parentheses and inside 3x plus 2y. And that's it for this lesson. Any questions, comments, concerns? Again, comments, message me, email me, ask me in class for those of you guys that are in my class. And this is it for chapter 6. I will catch you guys on the next one.